YouTube, this is UMOSO3. In the previous lesson, we've been talking about insertion sort, and we learned about another sorting algorithm, another approach to sorting a selection, to sorting a collection of sortable elements. Okay, so we talked about bubble sort, but we also talked about insertion sort. And we said these are two sorting algorithms which can sort not only integers and floats and also strings according to how they would appear in the dictionary, but also any elements that are sortable, right? So we built up this person class where essentially we have a constructor which assigns the values of the name and age instance variables. And then we have these property and setter methods, okay? And basically what this allows us to do is to return or change the value of a strongly private instance variable. So that's what we do from lines 112 to 118. And then the same thing happens with the age instance variable from lines 120 to 126. And so these are just part of our person class. And then don't forget the constructor, which again assigns the values of the instance variables when the object is created. And then we would have a str method. So this is a string representation of an instance of a class. And then we also have a less than and greater than. And we've been saying that this is the way that you would sort elements that are not just, integers or floats or strings, but person objects or point objects or hamburger objects or toothpaste objects. Anything can be sortable according to what Boolean is returned when I look to see if one instance of the class is less than another instance of the class. And so this greater than dunder is defined in terms of the less than dunder, which is defined in terms of the length of the name instance variable. So hopefully that's clear to you. And then in this video, I've also added on the length. So remember the length of an instance. Remember this is a dunder, so you can say the length of an instance. And what that would do, according to how we define it, is it would return the age instance variable, the integer division of the age instance variable with the length of the name instance variable. So if you had Alex and then you had an age of 20, right, it would be the integer division of 20, divided by 4, right? And so that would be 5, right? But even if so that would be 20 divided by 4, right? And so even if Alex was 22, then it would be 22 over 4, you would still get 5. So hopefully that's clear to you. And then we have this get item magic method, which allows us to treat an instance of a class as though it were a dictionary that we could stick keys into and get values out of. Okay, so that's what happens here is what if we said print u of name, where u is some instance of the person class? Well, that would return the value of the name instance variable for the instance u. What if you said u of dog? Well, apparently that would just return 400 for any instance. Okay, so it doesn't necessarily have to be instance specific, but if it is, you would say return self dot and then one of the properties of that particular instance. Okay, but that's not what happens with dog. With dog, you just return 400. Anything else, if you want, u of potato, it would just, print not valid. It wouldn't throw a runtime exception. You would just print not valid. It would return this string. Okay, so hopefully that's clear to you. And then what we also didn't have in the previous video, but what we've talked about before is the set item dunder. And this would allow you to basically do the same thing, but instead of retrieving values by passing in keys, you would be changing values by passing in keys. And so you would need to stick in basically the key that you want to change the value at, and then the new value that you want to have associated with that key. And so you would pass in the item that you're looking for, like the key. Like, for example, okay, do you want to change their name? Do you want to change their age? Okay, and so if you say u of name, then you would be able to update the name to whatever my val is, whatever my val is. So that would be presumably the new name, whatever you want to change the name of that instance variable to. But this allows you to modify the instance as though it were a dictionary that you could change the values of for particular keys. So hopefully that makes sense to you. But what if we said, u of whack equals something, right? Well, then it doesn't even matter what that something is, right? Because in this Boolean, if you say u of whack equals, right? If for this set item dunder, if you try to set the value associated with the key whack of the instance, to something, it doesn't matter what something is. So you would just say print Wacky Wednesday. So we can try a couple of examples here. So what if we basically said print length of u? So what if we want the length of, Tom and 81? So according to how we built it, it would be the integer division of 81 with 3. So now if we go ahead and run main.py, you would get 27. Okay, even if Tom was 82, you would get the same thing. The integer division of 82 with 3 is 27, right? And then what if we wanted to say, u of whack equals potato? So now if we go ahead and run that line of code, what gets printed? We get Wacky Wednesday, because we said if we try to stick in whack and change the value associated with that key, then we just want to print Wacky Wednesday on the console. So this is kind of a cool magic method. It's kind of a neat dunder that allows you to change a value associated with a key as though an instance of a class or a dictionary. So hopefully that's clear to you, right? And then if you did anything else, u of nothing equals potato, it would just say, what are you trying to do here? It would use the other Boolean. It would say, what are you trying to do here? Because the my item that you passed in, the first thing that you passed in was not name, age, or whack. So hopefully that's clear to you. But that demonstrates the length and the set item. And now what we want to do, remember also in the previous video, we talked about Lambda functions that don't accept any inputs. So here we have my function 4, which accepts no inputs and returns 77, and my function 5, which accepts no inputs and returns 15. And then we have my function 6, which accepts 2 inputs, f and g. The question is, what type of input is f and g? Well, if you look at this function definition, we have parentheses on f and g. So it kind of seems like f and g need to be 2 functions that accept no inputs, because what we're going to do is we're going to do the integer division of the outputs. So this implies, implies that f and g are 2 functions that accept no inputs and both return either, ints or floats, right? So one of them might return an int and the other of them could return a float. That's fine, but they have to be numbers, right? And so then what we've also talked about previously and what I wanted to review in this video is called function reference variables. So what we can do is we can create variables that refer to other functions, okay? And you wouldn't call them, you wouldn't have any parentheses or anything like that on the right-hand side of the equal sign. But what you would just do is you would basically say for a function reference variable, you would say basically a variable name equals function name, okay? And so it would just refer to the function. You wouldn't have any parentheses, so you would say no parentheses, and then but you would use variable name, of xy, just as you would have used function name of xy. So then whenever you call variable name, right, it would work the same way. But here, what we're going to do is we could say something like print ref4, right? Because ref4 here, my function 4 accepts no inputs. So that means ref4 would have to accept no inputs. So then if you go ahead and run that line of code, you would get 77, right? But then if you say on line 11 here, print my function 6 of ref4, ref5, it's going to stick in these 2 functions. So it's going to stick in basically my function 4 and my function 5, okay? And so according to the way my function 6 is defined, that accepts those 2 inputs, it accepts those 2 function inputs. This is called a nested function. We talked about how a function can be an input to another function, and that's what's happening here. And both of them have to return ints or floats, apparently, according to this definition. But you pass in those 2 functions, and then basically it would go ahead and do that. So it would do the integer division of 77 and 15, and that's why you see 5 printed on the console, because there are 5 full groups of 15 in 77. So hopefully that's clear to you. And the 27 was coming from later down here when we were talking about doing the length of the instance variable u. Remember, we defined that. We get to define what the length of an instance is, and apparently it's going to be the value of the age instance variable, the integer division of that with the length of the name instance variable. So hopefully that's clear to you. In the previous 3 videos, we've been talking about bubble sort and selection sort, or bubble sort and insertion sort, excuse me. And we said bubble sort is pretty simple, right? We said for w in range of length of my list -1, 0, -1, for x in range of w, if my list of x greater than my list of x plus 1, my list of x comma my list of x plus 1 equals my list of x plus 1 comma my list of x, return my list. This is a pretty simple implementation. This is called bubble sort. And we said that it's easy for you and me to think about, and it's not very many lines of code, but it's very inefficient, and it's not very good. It's not very practical, and you probably wouldn't see it in industry if you were trying to sort a list of 6,232 people. But we said that we can sort anything, and we could do it with bubble sort and insertion sort, right? So this is another type of algorithm where we would just pass in a list. And insertion sort, we said, is more efficient than bubble sort. We said it does things in a better way than bubble sort does. It takes the computer less time. It's less time complexity. So you would say for q in range of 1, length of my list. And you would say key equals my list of q, r equals q minus 1. while r greater than or equal to 0, my list of r greater than key, my list of r plus 1 equals my list of r equals r minus 1. My list of r plus 1 equals key, and then that happens after the while loop, but still within the for loop. And then at the end of the for loop, after the for loop, you would just return my list. What we're going to do now is we're going to talk about selection sort. We have to remember that these sorting algorithms work for not just integers and floats, but they also work for person objects and point objects. You just need a less than dunder, you need a less than magic method, and you really should be getting your own practice and taking your own time to make sure that you understand what it means for one instance of a class to be less than another instance of a class. What do you want that to mean? But for selection sort, this will accept a list again and return a version of the iterable where the elements are sorted in ascending order. Okay, so this works for numerical and lexicographical and other types of sortable elements, okay? And so it accepts a list and it's going to return a list. It's going to return the sorted version of the list. And we said we can't pass in a tuple unless we convert the tuple to a list and then sort the list and then convert that sorted list back to a tuple, because the tuple itself is not mutable. We can't change a tuple, but we can change the elements at the index positions within a list. So we would say for a in range of length of my list, and then we would say index equals a within this for loop. And then within this for loop, we're going to have a nested for loop. So we're going to have another for loop that says for b in range of a plus 1, length of my list. Okay, so these are the two inputs into the range command here. And you would say if my list of b is greater than, or I'm sorry, if my list of b is less than my list of index, index equals b, okay? And then finally, the last thing you put in the for loop is my list of a, my list of index, comma, sorry, my list of a, comma, my list of index equals my list of index, comma, my list of a. So what does this do? This swaps the values at index positions, you know, index and a. Okay, so it'd swap the values at those two index positions, because the goal, this is just another algorithm for sorting the elements in a list. And so what we probably should have done before we started talking about all the code is to understand conceptually what it is that selection sort is doing. And so what you could do is go to blackhole.com and look at selection sort, and you could look at the Wikipedia article. And again, this is not really just a Python thing, this is a computer science thing. So there's also a selection sort in Java, okay? And there's a video that I made, there's a 20-minute video that I made about selection sort in Java, but now we're doing selection sort in Python, not just for integers and floats, but also for strings and person objects and anything that you want. So it's a comparison sorting algorithm, so it makes it inefficient on large lists. So again, these sorting algorithms, these beginner ones sort of that we're talking about, are not very efficient, but they're good just for sort of understanding how algorithms work. And right, we've already talked about for loops, and we know how if statement works, and you know, variable reassignment and lists and index positions. So once we understand those fundamentals, we can understand selection sort, but it's still not a very fast algorithm. It's better than bubble sort, but it says it generally performs worse than the similar insertion sort, which is the sorting algorithm that we talked about in the previous video. Okay, but it's simple and has performance advantages over more complicated algorithms in certain situations. Okay, and so basically what it does is it divides the input list into two parts: a sorted sublist of items, which is built from left to right at the front of the list, and a sublist of remaining unsorted items that occupy the rest of the list. Okay, and so initially you're not going to have any elements in the sorted section, and the unsorted section is going to have the entire input list. But then you're going to keep finding the smallest element, okay, and you're basically going to exchange it with the leftmost, and you're going to keep moving the sublist boundaries one element to the right, okay, because you're going to want to keep growing the sorted list, and then you're going to want to keep taking values out of the unsorted list and putting them into the proper index positions where they belong, so that your list eventually gets sorted. Okay, so if you go on to Wikipedia, you can see different animations of this, and you can see that it's just sort of looking for the smallest element each time along the way. And so, you know, here it looks for the 6 and the 9, right? And so it's very quick here, and it's trying to demonstrate to you without taking too much of your time, but it's doing a lot of steps. It's doing comparisons at the same time. And unlike bubble sort, so with bubble sort, the only comparisons that we do are between two consecutive index positions, like my list of x and my list of x plus 1. But with insertion sort and selection sort, you could be comparing two elements that are a little bit farther away from each other. So hopefully that makes sense to you. But what you would want to do is, so we could operate this on lists, right? And you can see an implementation in C. And so this is relatively similar to the code that we wrote. Okay, the for loop is a little bit different. This would be a traditional for loop that you would see in Java or C, but not in Python. Okay, but it does something pretty darn similar. Okay, and so what we do, it has similar complexity. Okay, it takes a similar amount of time to bubble sort and insertion sort, but this is how it works. So you would say for A in range of length of my list, index equals A. And then also within the for loop, you say for B in range of A plus 1, length of my list. If my list of B is less than my list of index equals B. And then finally, with outside of the inner for loop, but inside of the outer for loop, the last thing you put in the outer for loop is my list of A, comma, my list of index equals my list of index, comma, my list of A. And then finally, outside of the for loop, to end the selection sort algorithm, you obviously need to return the list. You need to give back the sorted list to show people that your algorithm works as it's intended. So what we can do is we can try it on a list of numbers, right? We can do the same thing as we did in the previous video. Let's talk about summer temperatures. Summer temperatures. So we could be talking about 94, 88, 86, 90, 95, 91, 83, 80, 77, 81, 89, 96, 90, 92, 93, 89, 86. Okay, so hot to warm temperatures, right? And so what we could do is we could say summer temperatures equals selection sort of summer temperatures. And so you can pass in the input list, you can pass in the unsorted list, and basically it changes the variable to refer to the sorted version of the list. So hopefully that's clear to you, and we're getting a Python enhancement proposal saying that there should be at least 2 blank lines between a function and the creation of a new variable. So I just scooted it down from line 167 to 168. But now what we could do is we could say for u in, let's do a while loop. We haven't done a while loop in a while, so we could say something like my num equals 0, and then we could say while my num is less than length of summer temperatures, right? And then you can always press tab, right? If you're halfway through working through a variable name, one of the things you can do, I don't think I said it earlier, but you could just do summer, right? And then basically it recognizes that variable name, and then at least in PyCharm and probably in other integrated development environments as well, you could just go ahead and tab it out, and then you could say, you could basically say print, and then you would want to do summer temperatures of my num, right? And that would be a little bit more work than the for loop would be, because you'd have to go ahead and then remember to increment the value of my num. But that will go ahead and be able to print the sorted summer temperatures. So now you can see that the temperatures increase for 77, 80, 81, 83, 86, 86, right? And it's okay to have duplicates, right? So there's a couple 90s and there's a couple 86s, right? But hopefully that makes sense to you. And then you can also do the same thing for objects, right? Like we've been saying in the previous couple videos, you can also do this for objects, right? So let's go ahead and remove all that code, but you could do the same thing now. Instead of doing insertion sort for these person objects that we created, remember we created 6 instances of the person class, and then we basically put them into a list called my people. And I think we did that in the previous video, or maybe about 2 or 3 videos ago. But what we could do is we could say my people equals selection sort of my people. And so basically it'll return the sorted version of these person objects according to the length of the name instance variables. That's what we said we wanted the less than dunder to do, right? That's how we said we wanted A less than B to be defined for 2 instances, A and B, of the person class. So now if you run the executable Python file, you get the same result. You see that these 6 person instances have been sorted according to the length of their names, right? And so then this would work, and then you can do this as many times as you wanted. So you can say another guy, right? And then you could say person. This can work for you know, Yolanda, right? And then you could say 800, right? Doesn't matter, the age instance variable doesn't matter, right? But then if we say another guy back here, and then you could go ahead and run the same thing, right? And then here you'd see Yolanda appear where it belongs, right? And then finally, we also talked about Lambda functions that don't accept any inputs. So this is an example of a Lambda function that accepts 2 function inputs. You can see from the definition of the function that accepts 2 function inputs that don't accept any inputs, right? But they have to return ints or floats. Okay, so that's what we do. And then we have function reference variables, which we'll review a little bit more in the next video. But now you have 3 sorting algorithms at your fingertips, not just for ints and doubles and floats, but also for strings and objects. From UMOSA 3, thanks for watching and please subscribe.